Thank you for attending our webinar. My name is Thomas Lewis. I am the account rep for the Southeast. I'm joined today by Hall. And just as a side note, I do have a dog in here that may cough or make some other noises. Pay no attention to that. And I apologize in advance for that. But again, thank you for attending this webinar. We will be going over the Direct Plus, Flex, and Max nose boxes that we offer. The scope of this webinar will cover the basic functions of all three of the nose boxes, diagnosing liftgate charging systems, and diagnosing the input sources, being the tractor and the reefer unit. Now, depending on what box you're using, what company you work for, we do offer three different nose boxes. The first one on the left is the Plus. That's a single source nose box. It does have a 7-way socket on the front. And that is you just be charging through the 7-way aux pin. The middle one is the Direct Flex. We have a dual pole socket on the left and a 7-way on the right. You can charge using a dual pole socket and a 7-way on that. The Direct Max is the same as the Flex, except it comes with what we call severe service cables that are linked directly to the liftgate battery. So that unit kind of charges in parallel of itself. It directly charges the liftgate batteries through the battery cables, and it will charge through our DC to DC converter and liftgate charging system. All three of them do come with dome-like controller switches, so we kind of threw that in there as a bonus. You can charge your liftgates and power your dome lights. So, going to go over a couple of the scenarios when you're looking at the nose box. You'll see either a solid light or a blinking light. What these mean, and I always say, you as long as you have lights, you can kind of diagnose what's going on. A solid green light means that the system's working. It's charging, hooked up to the tractor, or the reefer unit is running and it's charging the batteries. The solid green means the batteries are charging. A blinking green means that it's not charging, but the batteries are at a good state of charge of at least 12.4. So those are the two scenarios that most of the time you'll see if you walked around the yard where the trailers are dropped. A blinking green light, if it's not connected to a tractor, that's good. So now we'll cover the lift battery. If you see a blinking orange, that doesn't mean that it's bad. It just means you got low voltage. The liftgate batteries are at a state of charge of 12.4 below. Blinking green, again, is good. No light means there's a blown 2-amp fuse, and that's in the battery box. We'll cover that in a second. But it means there's a blown 2-amp fuse, or the battery voltage is under 7. Easiest way to check that is obviously go to the battery box and put your multimeter on the battery, and if it's around there, then that's where obviously the issue is. Source LED goes right along the same lines. Blinking orange, low voltage below 12.4. Blinking green, good voltage above 12.4. And no light, again, blown 2-amp fuse or voltage is under 7. And I think Paul will take over from here.
Yeah, thanks, Thomas. Yeah, so like Thomas mentioned, first off, hi, everybody. I'm Hall Fess. I'm the account manager here in the Midwest, based in Chicago. Like Thomas mentioned there, so all of our nose boxes come with those LED lights for to help diagnose certain things, the voltage of the batteries. But there is a situation where you might not see any LED lights lit up. And so we're going to kind of run through what that means and how to diagnose that. Generally, if you don't see any LEDs lit up on the front, the main cause, what we usually see, is that the 2-amp fuse at the battery box is blown. So if you look at the picture on the slide that you're seeing right now, just below the connector going into the DC to DC converter there, you've got the fuse holder, and that's the 2-amp fuses in there. The reason we put it there is that circuit is sending a signal up to the front of the trailer, up to the nose box, and that is both powering the controller and sending a signal for the liftgate battery state of charge. If in the past, before we had that fuse in line, if there was a short or something at the battery box, it would send that up to the front and it would cause a lot of damage in that controller. So we just have that 2-amp fuse there as a bit of protection. It's really small because that signal should be a really small amount of power going to the front. So if you do see it blown, just make sure that you're also replacing it with an appropriately small fuse. If you put anything bigger in there, it could cause more damage. So just keep that around 2 amps whenever it's replaced. If you go back and check it and that is the 2-amp fuse is good still, then like Thomas said, you'll probably have a voltage issue. Sorry, real quick before we go on, just a recap on testing those fuses. There are a few different ways to test it. I know a lot of the first instinct is just pull it out, hold it up, look at it, and see if you see see if it's blown. A lot of times what we see, though, or sometimes I should say, is that there will be a small little break in the fuse. It's not fully blown, but it's not allowing the voltage to pass through, or it is fully blown. It's just hard to see because it might be a small break. So what we generally recommend is when you're testing the fuse to see if it's blown or not, use your multimeter, set it to ohms, and place one lead on the positive and one on the negative. It doesn't matter which is which. And what you're looking for is a 1 ohm or smaller reading. That indicates the fuse is still good. If it reads OL, then you've got a bad fuse. So assuming that fuse is still good, we're going to go check the battery voltage. Like Thomas said, you can check directly at the batteries just to make sure you have good voltage there. If you don't, go ahead and charge those up, test them, and try again. Assuming that you do have battery voltage above 7, we're going to follow this circuit to make sure that voltage is actually getting where it needs to get, which is the nose box of the trailer. So next place we're going to, step 2 here, is you're going to check voltage levels at the orange wire connected on that 2-stud terminal strip. So you're going to put the positive lead on the top stud on that strip, which is the orange wire, negative lead on the ground, and you're looking for, essentially, you're just looking for that liftgate battery voltage. And it should be above 7 volts. If you see good voltage there, then you're going to follow that circuit all the way up to the front of the trailer, to the nose box, and you're going to measure the exact same thing at the nose box. You're going to look at the orange wire and the ground there and see what the voltage is there. It should be, if not exactly the same, due to some voltage drop. It might be a little bit different, but it should be above 7 volts and very close to what it is the liftgate batteries up there at the nose box. So if it's not, then you've got a problem along that wire running from the liftgate batteries to the nose box. You need to check that for a cut or corrosion or whatever it might be that's keeping the voltage from getting to the front. Assuming that you do have good power there, and you still have no lights on the nose box, then we might need to get a replacement nose box out to you. But generally, one of those two things is the cause if you don't see those LED lights. Thomas will jump in and run us through what happens if your batteries aren't charging at all.
Thanks, Hall. So a couple of things when the batteries aren't charging. First, probably the most simple explanation is it's not coupled to the tractor. That's a easy remedy and only takes back in the tractor to the trailer, connecting the ABS cord or dual pole socket. Little note, I know it's mentioned before, but voltage must be at 3.8 in order to start our liftgate charging system. That usually happens right when the truck is cranked. No big deal, but that's the most simple explanation why the batteries aren't charging is it's not tethered to the truck. Second step, we're going to measure the voltage in the behind the nose box, black wire, input positive and ground, and you should be getting the truck voltage. If not, we're going to check that 30 amp fuse in the battery box to make sure that it's not blown. And just as with the 2 amp fuse that Hall was going over, same way, set the multimeter to ohms. Obviously you can pull it out and look at it, but sometimes those are that smoke color and it's hard to tell. So this is obviously just an easy way, positive and negative on the leads. On ohms, if you get 1, it's good. Oh well, out of limits, you're bad. Replace that fuse. Step 3, if that's not the issue, measure the voltage at the yellow wire. That should be around 12 to 13 volts, and if not, then as Hall was saying, let's look at those connections and make sure that everything's tight. Make sure there's no corrosion on the terminals or the terminations. If there is, clean it up, tighten it down, and that should work good. Step 4, if all those scenarios don't give you an answer, we're going to go back to the battery box. Excuse me, and that's the plug. What you see in the slide is the plug that goes into our DC to DC converter in the battery box, and we're going to start testing those pins. So positive lead will go on the black, the number 1 pin, and negative obviously the ground, and that should be giving you information on the tractor voltage. And if it's not, and there's no voltage there, then there's something that's in between that plug and the front of the trailer, maybe a damaged wire, cut harness, something like that. But I would follow it from the battery box up to the front of the trailer and see what damage there is. Step 5, we're going to follow the same procedure, and we're going to check the pin 3 and pin 4, the yellow wire, and it should read 12 and 13. If not, then we're going to go through the same thing from the battery box up, check that wire, check that harness, make sure there's not any issues there. Step 6, again, the same procedure. We're going to check those circuits, the ground and the number 2 pin DC to DC converter output. And this should be the same voltage as your batteries. And if not, you may need to reset that 30 amp circuit breaker that's back there connecting the two, or even repair the circuit, or repair the circuit. and Hall's going to take over and do a few of the other LED scenarios that we might see.
Thanks, Thomas. And just one thing, I want to jump back to this last slide. So obviously we want to check for voltages within that Deutsch connector. They were also on some older systems have had some issues that you might see where this water or something has gotten in that connection with the Deutsch connector, and it could overheat. So if you do take it out and you see that it's black on one of those pins, first off, just go ahead and clean it off. A lot of times that's just surface damage or a surface level something. And so if you clean it off, it might still work. If not, you can just replace that one harness. We have found a fix for that, and all systems within the last 6+ months, I think, will have that fix. So shouldn't see that much moving forward, but that is an issue that has come up in certain situations in the past. So if you do see that, first go ahead and try to clean it. If not, we can just get that one harness replaced. That's a very easy replacement that we can get out to you as soon as possible. So, all right. So a few other LED scenarios that you might see here on the front of the trailer. One of them is you might see one of the lights flashing really quickly orange. And this is actually a built-in diagnostic code that is designed to show you when you have a blown fuse behind that nose box. So we have fuses on the ground and power side of the circuit within the nose box. So if one of those does blow, you'll see that rapid flashing orange light on the front. And that's generally 99 times out of 100. I think every time I've ever seen it, it just tells you that there's a fuse blown in there. If you do open it up and check it and the fuse is good, then you've just got some sort of open circuit in there. It might be loose connection, it might be a broken wire, but that should be pretty apparent. Looking kind of playing with the wires in there just to see. But again, 9 out of 100, maybe more than that, it's just a blown fuse. Just again, one more time, just like before, if you're checking those fuses, we recommend checking that with the multimeter to make sure you get that sure test and don't get don't have any issues or any false tests. So real quick, I just want to go through a few of the call outs here, mainly just to show between the Direct Plus, which only has a 7-way plug, and the Direct Flex or the Direct Max, which will be on the next slide, that have the 7-way and dual pole plugs. There are some different things going on, but the main thing I want to point out is the things that are the same that are going on and the things that you'll probably be checking most. So, which would be the fuses if they do blow in here. We have the ground fuse, which is, so this picture that we're seeing, is actually upside down. It's positioned as if you're taking the nose box off and looking at it. So the one on the left side here is the ground fuse. The one on the right side is the power fuse. So on the same, I'm actually going to go ahead and go to the next slide just so you can see the comparison. Here you see the same thing. It's still the left side is that ground. The right side is the power. And then within that we have the callouts for all the other different pieces, whether it be the nose box or the dual pole or the 7-way. These are in our diagnostic guides, which are online if you would like to download those and have those to look at. All of these connections should be connected when you receive, if you're installing, these should all be connected from Purkeys. See if there was anything else I wanted to point out here. Yeah, the main thing is just knowing which of those fuses is which. And the reason some people ask us why we fuse the ground circuit. So the reason we do this is because since our system is charging Liftgate batteries, we do have the Liftgate pump motors to deal with back there. In the past, when we first started doing this 15 plus years ago, if there was a bad ground on the pump motor and the liftgate was trying to pull 150 amps, that system would look for a ground somewhere. And it would inevitably find our wire, which is only an 8 gauge wire and is not designed for 150 amps to flow through it. So we ended up putting a fuse on that ground side just to add some protection. I'm getting a little bit of feedback. That might be Thomas. Can you mute if you're not? Sorry. So as you can see in that picture, if we didn't have that fuse, this is what could happen. The jacket we have on the wire, the insulation is designed to just, it would melt if it overheats. It's not going to smoke or set on or light up or anything like that. But this is the kind of damage we had seen before we had that fuse in place. So that is why we fuse the ground circuit, in case you were curious. And that is just something to check if you see that rapid flashing orange light blinking. Another situation that you might see are blue LED lights. So what this means is if the power of the liftgate batteries gets disconnected and then reconnected, the blue LED lights just indicate our system is completely resetting. So what'll happen is they'll come on, our system will go through all its checks. It's kind of sending signals saying, hey, are you okay? Are you okay? Is everything here? Are we all connected? Once that has been established, then these lights will go back to their normal blink codes. Occasionally, though, they will stay blue and they won't go back to their normal codes. If that happens, that means that those liftgate batteries are kind of right on the edge of that 7-volt threshold that we talked about earlier, where they need 7+ volts to get power. So if they're right around there, our system will see enough power to say, okay, there are batteries here, but not necessarily enough power to turn on. So the lights will get stuck on that blue that blue setting. So if that happens, you just want to take the liftgate batteries, test them, make sure they're still good, and charge them up, and then reconnect them, and everything should be good to go. So there's one more. There's one more blink code that we're going to talk about, and this is probably the one we see most often. And generally we see it on systems charging through the 7-way, and that is a voltage drop issue. So before we kind of dive into what that issue looks like and why that occurs and all of that, since it does have to do with the input source, we're going to kind of walk through exactly what those sources are and what they need before we jump into to that issue. So the first source that we're going to talk about, because this is the dual pole and single pole, and the reason we're going to start with this is because on our system there's kind of a hierarchy of which source is the best one to charge from, and dual pole is always going to be the best. It's going to be the first choice that we do. So if our system's plugged in, it's got the 7-way and the dual pole plugged in, it's going to choose the dual pole every time. In order for that dual pole to work and to function and charge our system, we need to have 13.8 volts at the nose box. So, and we also need to make sure that all the connections can support the 20 to 25 amp load that our system pulls. If we do not have enough voltage, or if there's a fuse that's too small or something along the way that can't support the load, then that dual pole won't work, and we'll have to go to the next source, which is, there it goes, is the reefer. So the reefer is going to be the next source along that hierarchy. You can see in this picture where we've got the harness that will connect up into the reefer. This harness has a 30 amp fuse built in, so it's everything is that we make is designed for that 30 amp circuit and is protected. But if the reefer is not putting out the 13.8 volts that we need, or if there's something else along that circuit that is not protected with for the 20 to 25 amp load, or cannot support that, then this reefer our system will not charge off the reefer, and we will move to the third source, which is the 7-way circuit. And again, just like with the other two, we need 13.8 volts, and it's got to be able to support that 20 to 25 amp load. So this brings us to the voltage drop, which is the most common fault that we see. Now, the reason that we mostly see this on the 7-way is because there are so many other things going on the 7-way circuit. There's so many other things demanding the power from that aux pin. And also because two of the most important things on that circuit are the ABS and the roll stability. So we always want to make sure that those have the power they need, which means that if the voltage drops below 9.5 volts, our system charging through the 7-way is just going to shut off. It's just going to back out and make sure those other systems have enough power. So because of these two things, that system is just a little more sensitive and has higher demand upon it, which means that it's more likely to have voltage drop issues. So what exactly do I mean by voltage drop? This happens whenever, so let's say you plug in the tractor to our Liftgate charging system, and those lights go solid green, which, like Thomas was saying earlier, means that the system is on and is charging. So everything looks good. And then it'll take about 20 to 30 seconds, probably less than that actually, and those lights will toggle back and forth orange really quickly. So what's happened is the system has seen the power from the truck, it turns on, the DC to DC converter in the battery box starts pulling that load, and under load, there's voltage drop along that circuit that causes the voltage to drop below that 9.5 volt threshold, and our system shuts off because we're protecting that ABS and the roll stability. So when it shuts off, the lights toggle back and forth orange, which is our system resetting itself. Once it's reset and the load is turned off, then the voltage jumps back up above that 13.8 volts. Our system turns back on and tries it all again. So you kind of get this cycle of it goes green, then flashes back and forth orange, then goes green again, then flashes back and forth orange, and so on and so forth. So in order to, there are some specific ways to avoid this and diagnose this if you do see it on your trailers. And Thomas is going to go into those now.
Okay. Again, we're going to start at the very front. We're going to start in the tractor and go into the fuse box, and the first thing we're going to check is the 7-way auxiliary fuse and make sure that's not blown. Again, as we said, our system is designed to work in conjunction with a 30 amp fuse. Make sure that's a 30 amp fuse. Sometimes it can be less, and that fuse can get blown pretty easily if it's not. The next place we'll check is the 7-way connections, or the dual pole connections. This is a part of the tractor that it's underneath the tractor. There's all kinds of road salts, magnesium chlorides, and they start spraying up, especially obviously in the winter. But they're exposed to the elements. Make sure those connections are tight. Make sure they're not corroded. Obviously, depending on what state you're in the U.S., some roads are better than the others in different states, and you can definitely from the vibrations going down the road, you can get loose connections. Go back there, make sure everything's connected, secure, no corrosion, and make sure there's no cuts in the harness or chips out of it. Next, we're going to look at the nose box. That's, I commonly refer to it as a rat's nest, because all those wires are jumbled and crammed in there. And when you go to when they're first installed and you go to push it back on, all those wires just kind of get pushed all together, and depending on what kind of termination you use, whether it's the push-on terminals or ring terminals, we like to use ring terminals because we feel like it's the most secure method. You slide those on the post, tighten it down. You make sure it's nice and tight. Push-on terminals are good. They're quick install. But again, we definitely prefer using the ring terminals, because sometimes when you slam that box back on and you secure it down, the pins can come off the post. Also check for exposed wire on those, and make sure everything's covered up. Again, the vibrations going down the road, if there's exposed wire and it starts touching, that's when you know, sparks are flying or shorts happen. So make sure everything's tight. Make sure everything is nice and clean. There's no corrosion in there. And you know, once that's the easiest way to eliminate voltage drop inside the nose box. More often than not, we find so many just loose connections, loose grounds. So make sure everything's tight, nice and tight. The next way is the 7-way ABS cord. Those are the first thing that, or one of the first things that I mean, they're exposed to the elements. They're exposed to being stretched out, you know, backing in tight places and just going down the road, turning right and left. Those cords get pulled. The connections within the plugs will sometimes they'll pull out of the pins. It's, you know, I know it's not supposed to touch the deck of the trailer, but that deck can be sharp and it can cut the jacketing on those ABS cords. That's probably one of the most commonly replaced items on the back of a cab. Also, when a truck is not tethered to a trailer, it's stored, either it's put into the caddy, the ABS caddy, or it's just kind of hung up there. Either way, if it's put into it, a lot of times the weight of that copper will bend down, and it's a clear shot for rain to just get in there and get in the back end of that plug. And that's once water gets in there, starts getting into that the inside the wire and the jacketing. It'll wick its way all the way down that cord, and once you put power to it, you hook up the truck and the trailer, electricity is just going to accelerate that process of corrosion. So check those ABS cords. Make sure they're tight. Also, the pins within those ABS cords can become loose. So a lot of them, if you look close, they're split, and the connection won't be as tight. So a lot of times you behind a trailer going down the road, a lot of times you'll see flickering lights. That's what that's to do, or that's why that's happening. In a lot of cases, is the connection ain't good, and it can stem right there at the ABS cord. This is a product that we developed, the Liftgate DC or double check. This particular picture, it will allow you to put a load on the circuits. So we have adapters that will allow you to plug the 7-way cord in it to test the 7-way. It'll also allow you to plug directly into the tractor 7-way. Also, we have adapters to test our system, the nose box. Again, when you're testing the truck, make sure you put it under a load, and that's the second box right there to your right. That will apply a 20 amp load, which is enough, because sometimes there could be voltage, but when you apply a load to it, it's not going to be the same. So this is a tool that we developed in order to help test some circuits.
Yeah, and just to jump in real quick, Thomas, and reiterate that point, because that is probably the most important point along this whole thing. The thing we get most calls about is whenever you're testing that circuit, looking for a voltage voltage drop issue, you're not going to see it unless it's under some sort of load. Otherwise, the voltage is going to look great. So you need to make sure whether it's using this tool or whether it's plugging it into something you develop, just something that's going to pull a significant load on this circuit to make sure you're getting an accurate reading. So just wanted to reiterate that.
Oh yeah, thank you. So some of the troubleshooting resources that we have available, we have an installation guide. Every single one of our pieces of equipment that we ship out comes with an installation guide. I know when I was a kid and I used to put models together, I didn't read the directions, but that was just plastic. Every one of our units comes with an installation guide that, especially if you haven't installed but a few of them, it should be read. We also have diagnostic guides. Once you've read the instructions and installed it, if there are issues, we can help diagnose it. The lights, anything that's going on, we can help diagnose that, and that's the LED status and logic cheat sheet. So we can kind of tell what's going on with everything. And lastly, we've got a technical support team that is top notch. You can call the number, excuse me, you can call the number that's listed below, ask for our tech team. They'll put you in touch with one of them, and you can tell them, hey, this is what's going on. They'll walk you through the steps to kind of figure it out, get it corrected. A lot of times, like we've been saying in this webinar, it's as simple as a loose connection. But they can help walk you through that. If you need something a little more and you need somebody to come out, we're more than happy to send somebody out as well. They do a fantastic job of supporting our products and supporting you. And last, our gift for attending this webinar is a multimeter kit. Has everything that's pictured there. $189.99, the low price of $189.99, and then we also have our double check for sale. I know it doesn't show it, but it comes with all the different adapters to check the ABS cord, the 7-way socket on the back of the truck, and to test our system. It's got a dual pole socket, or excuse me, a dual pole plug, single pole plug, 7-way plug. It's got everything you need to do that, and that is $585. Again, that is thank you for attending our webinar and listening to us. Hall, do you have anything to add to that, or if not, we can take questions.
I do not. Yep. Just ready to take whatever questions you got.
I wonder, did it cut out?
No, I think we just must have explained it pretty well. But just want to kind of reiterate. We'll go ahead and wrap up here. Feel free to keep still you got them, but I will start wrapping up. If just want to reiterate that we do have all those resources online, and we have our tech team, like Thomas said. If you've got anything you need from us, if you have any questions about the promotion, I believe mine and Thomas's information is online as well, so feel free to reach out to us directly. If you wouldn't mind staying on for a couple minutes, we've got a quick survey at the end of this, and we would very much appreciate your feedback. So thank you, everybody, and have a great day.
Thank you.